Okay, let's dive into this. Welcome to The Explainer. Today we're talking about something so completely omnipresent that we usually just take it for granted. We're going to unpack the invisible mechanics of our atmosphere, tracing how a simple, everyday weather forecast actually connects to the massive global systems that govern all life on Earth. By the end of this, you're going to see the sky, the seasons, and our entire planet in a beautifully structured, brand new light.
So let's start right where you are. I want you to do a quick mental assessment for a second. Think about your immediate surroundings. What's it doing outside your window right this very moment? Is it bright and sunny? Is it pouring rain? Or is it maybe just totally still and cloudy? Even on a quote-unquote still day, there are literally thousands of tons of water floating right above your head. Whatever you're picturing right now, you are anchoring yourself in our very first concept. You are observing today's weather.
Weather is, strictly speaking, the short-term reality of the atmosphere in your specific location. It's the ultimate in-the-moment data point. It changes from morning to afternoon or even from minute to minute. When we talk about weather, we are entirely focused on the present, highly localized moment.
But that weather you're seeing, it's actually a pretty complex recipe made up of 6 core ingredients. Temperature and rainfall, well, those are the obvious ones. But consider air pressure for a second. That is the literal, invisible weight of the sky pushing down on us. Or humidity, which dictates how efficiently our sweat evaporates into the surrounding air. And meteorologists, they don't just note that the wind is blowing. They track the precise intersection of its speed and direction to mathematically model exactly what's coming next.
Let's move to and see how this all builds together. This daily data fuels a massive continuous pipeline. It literally starts out in space, with satellites tracking the sun's interactions with our atmosphere, and trickles all the way down to local ground stations. Meteorologists then feed mountains of this data into supercomputers to model predictions, eventually beaming it right to your phone. It's a completely vital infrastructure. This dictates everything from global agriculture scheduling to the routing of massive cargo ships, all the way down to your morning commute.
Now what's really interesting about this data collection is the highly specialized hardware scientists rely on. The real unsung heroes here are instruments like the barometer. A sudden drop in air pressure is often the very first invisible clue that a massive storm is brewing, long before a single cloud ever appears. Meanwhile, anemometers use chaotic fluid dynamics to calculate exact wind speeds. It's kind of wild to think that hundreds of years ago, the first anemometers were just swinging wooden plates pushed by the breeze, and today they are the high-tech cornerstones of global weather tracking.
If we zoom out, over the course of a year, all this daily weather aggregates into a broader, predictable pattern that we know as the cycle of seasons. Depending on where you live, you might experience a distinct summer, a monsoon season, autumn, winter, and spring. And these shifts are massive. They completely dictate our lives, changing the seasonal foods we eat, the agricultural cycles we depend on, and even the cultural festivals we celebrate. But why do we even have these seasons? Well, the mechanics here are entirely cosmic. Because the Earth orbits the Sun on a tilted axis, the distribution of solar energy, which scientists call insolation, is constantly shifting. When your hemisphere tilts toward the Sun, you receive highly concentrated, direct radiation, which we experience as summer. Tilt away, and that exact same energy scatters over a much wider area, bringing the freezing temperatures of winter. Zooming out even further from the seasons brings us to the ultimate macro view, and that is climate. Now, climate isn't just a long time, it's a rigorous statistical average. You can't just define a region's climate by looking at a single year. It requires aggregating daily weather data over decades, typically a 30-year baseline, to find the true atmospheric normal. That long stretch of time acts as a statistical smoother to weed out all those short-term anomalies.
So the crucial point is really understanding this ultimate showdown between weather and climate. Think of them as two ends of a spectrum. Weather changes quickly, it happens daily, and it's highly localized. Climate, on the other hand, is the long-term, slow-changing reality of a massive geographic area. The contrast is simple but profound. Weather tells you what you need to wear today. Climate tells you what wardrobe you need to own.
So what actually engineers these long-term climates? It's a complex interplay of geography. Your latitude, your distance from the equator, dictates your baseline solar heat, but that's immediately modified by your altitude, ambient humidity, prevailing winds, and massive ocean currents acting as global conveyor belts. These currents transport millions of cubic meters of warm and cold water across the planet every single second, completely rewriting the climate of the coastlines they brush up against. Let's look practically at two of those really impactful factors: proximity to water and elevation.
The ocean essentially acts as a giant planetary thermal battery. Coastal cities enjoy the water's regulating buffer, which keeps their climates remarkably moderate. But if you move inland, away from that thermal battery, you are suddenly exposed to massive, extreme swings. We're talking blistering summers and freezing winters. And altitude? Higher elevation means lower atmospheric pressure and thinner air. That's exactly why mountains can have snowcaps while the valleys right below them bake in the sun.
Because a climate is semi-permanent, human survival has required some serious, ingenious adaptation. I mean, we literally engineer our habitats to fight the surrounding environment. Just look at architecture. In heavy snow climates, houses feature steep, sloping roofs to shed crushing snow weight that would otherwise collapse the entire building. We build flat roofs in arid deserts, and we construct elevated stilt homes in monsoon regions just to let torrential floodwaters pass harmlessly below our living rooms. And nature, of course, is the ultimate adapter. Plants and animals undergo incredible physical adaptations over generations just to survive. If you look at the biological extremes, from water-storing cacti and heat-dissipating camels in the desert to heavily insulated polar bears and pine trees in the freezing Arctic, it shows how the long-term climate literally dictates and shapes the biology of every living thing within it. And this brilliantly illustrates what happens when the macro system itself shifts. The sources trace a specific, cascading cause and effect pipeline here. Increased industrial human activity releases massive amounts of greenhouse gases, which trap heat and raise the planet's baseline temperature. This global warming directly destabilizes those massive geographic factors we were just looking at. The result is the acceleration of extreme, unpredictable events, things like severe floods, prolonged multi-year droughts, and the rapid melting of ancient glaciers. But because the climate is a closed global system, micro behaviors ultimately dictate macro environments. Actionable adaptation means everyday choices that aggregate into a planetary impact. It's about planting trees to naturally sequester carbon, conserving our local water and power grids, and shifting toward public transit to lower overall emissions. It's a really structured approach showing how individual routines actually scale up to protect the broader climate profile.
Which brings us to a powerful summarizing thought to close our explainer. Small actions today create a better climate tomorrow. We've seen how fleeting daily weather builds the massive 30-year engine of climate, and how that climate shapes our architecture, our wildlife, and our very survival. It is all deeply, beautifully interconnected. The micro always influences the macro. So, as you look out your window at today's weather, I want to leave you with this to consider. What micro choice will you make today that will echo into the macro climate of tomorrow?